Alright, we finally made it to this magical thing called a logarithm. And all a logarithm is it's the inverse of an exponential. It looks big and scary, but it really isn't so bad. So example of inverses would be addition and subtraction, multiplication and division. They're just inverse of each other. They undo each other. But the logarithm requires that you know the definition. If you can memorize the definition right here, it'll be much easier. You won't be able to really do anything until you have this logarithm definition memorized. So it comes from the exponentials. The exponential's base was greater than 0, and it was not 1. The log was the inverse of the exponential. So that means the domain and the range was switched. So the domain is the range of the exponential. So the domain of the logarithm is 0 to infinity. So remember, here is your exponential, here is your logarithm. So here's your log's domain, can't go past 0. Okay? So log base b of x, log base b of x is equal to y, is equivalent to, or if and only if, b to the y power is equal to x. So one little trick you can do is your log's always equal to the exponent, so b to the y power. b to the y power is x. Log base b of x is y is equivalent to b to the y power is x. Log base b of x is y is equivalent to b to the y power is x. So maybe you got to say that a couple of times, kind of get the hang of that. Okay. Now we're just going to practice going from exponential form, which is this, to logarithmic form, or from logarithmic form to exponential form. You need to be able to go back and forth because it's going to make your life a lot more pleasant when dealing with logarithms, and you won't be able to do anything until you get this definition down. It's just new. It's not that hard. It may look big and crazy and scary, but it's not so bad. Alright. I'm just going to write the definition of log in, and we're going to do a little table. It's going to find the base, the exponent, logarithm, and the exponential. So I'm going to give you one form, and then to help things out, identify your base, identify your exponent, then I'll probably either give you logarithmic form or exponential form, and you got to try to find the others. So I'll give you 2 cubed is 8. If you want to pause the video for a second and see if you can identify the base and the exponent, go ahead. And then see if you can use your definition of log to write it in logarithmic form. So right now we have b to the y power is equal to x. Our base is 2, and our exponent is 3. So we're going to have log base 2 of x is equal to 3. So your logarithm is always going to be an x. Is always going to be the exponent. So log base 2 of 8 is 3. 2 to the 3rd power is 8. Okay? Now I'm going to give you a logarithmic form and see if you can identify the base and the exponent, and then try to put it in exponential form. So log base 3 of 81. Okay. Alright. So if you want to pause, see if you can try to figure it out. It's going to be 3 to some power is 81. Base is 3. And what I'm going to do is I'm going to put it over here in exponential form on the right to see if I can find what that exponent is. 3 some power is 81. And it's going to be 3 to the 4th. 3 to the 4th is 81. So that's what my exponent is, and that's what my log. 3 to the 4th is 81. Okay? So just kind of take a little bit of repetition. You'll get the hang of going back and forth from exponential to log form. Okay, so what if I throw in a negative exponent? It's not going to be a whole lot different. 2 to the negative 5 is 1 over 32. So if you want to pause it for a second and see if you can find the base, the exponent, and then try to find the log form. Your base is 2. Your exponent is negative 5. So it's log of your base, which is 2. Your log is going to be equal to negative 5. So the only other place for the 1 over 32 is going to be inside the logarithm. So log base 2 of 1 over 32 is negative 5. Okay? Not so bad, is it? Alright. I think we're going to have one or two more on this page, and then we'll do a couple more. Alright, what if I say log base 8 of 64? Okay. So I already gave you the base. If you want to pause it and try to find what the exponent is, you can. Log base 8 of 64 is going to be 2 because 8 squared is 64. So 8 squared is 64. So that's what my exponents could be. So log base 8 of 64 is 2. Alright, what if I give you one where I give you the base and I give you the exponent? So, see if you can write the exponential in log form. Base is 5, exponent is negative 3. Okay? So 5 cubed means 5 times 5 times 5. So that's 125. The negative is going to send it in the denominator. So that'll be 1 over 125. Okay? Now we got everything we need. We got the base, we got the exponent, and then we got the argument. Okay, so the base is going to be 5, the exponent is going to be negative 3. Remember, your log is always equal to an exponent. That puts the 125 inside the argument of the logarithm. So log base 5 of 125 is negative 3. Okay, so I think I got 2 or 3 more examples of just going back and forth. Okay, we'll write the definition of log. Set up the table. Okay, if you want to pause the video and try to do this, go ahead. Okay. If we look at the first one, the base is e, the exponent is 7. So in the exponential form, that'd be, and logarithmic form, we're still missing some stuff. So base is e, exponent is 7. If you want to plug that into your calculator, a lot of calculators will have an e button. And e to the 7th is probably going to be a pretty large number. E is 2.71 approximately. But use the E button in your calculator because it's going to give you a more accurate number. So you can say whatever e to the 7th is, or you can just leave it as e to the 7th. Okay. So log base e of e to the 7th is just going to be 7. Okay. Another thing is on your calculator you'll have a button that says ln. Natural log, e is called the natural number. Sometimes it's called Euler's number. Natural log is so special it gets its own button, ln, and what it means is log base e of x. So if you see ln anywhere, then it's got its own special notation. Okay, you will also have this button on your calculator. You have log. Okay. And this is what's called maybe common log. And ln is called natural log. So your calculator will most likely have those two buttons. Common log is log base 10 of x. So if you don't see the base, it's understood it's 10. Kind of like when we just say x, we mean it's like 1x. We just don't write it because mathematicians are efficient or lazy. So that's just the convention. If you just say log, we mean log base 10. If we say ln, we mean log base e. Alright, so now if we look at the second example, log base 3 of x plus 7 is equal to 5. The base is 3. Your logarithm's always equal to its exponent. Exponent is 5. And then logarithmic, or in exponential form, 3 to the fifth is equal to x plus 7. And we're actually going to solve a logarithmic equation. So the first thing we do is we convert it from log form to exponential, and then we can go ahead and solve that. So just rewriting, put it in exponential form, and then we can go ahead and solve this. So we'll subtract 7 from both sides. And whatever 3 to the fifth is, I don't remember, I think it's like 729 or something along those lines. And then subtract 7, that's going to be your x. So you can go ahead and crunch those numbers if you want a definitive answer instead of 3 to the fifth minus 7. Alright. Now let's look at that next one. Log base 5 of 625 is equal to 4x plus 2. Your base is going to be 5. Your exponent is what your log's equal to, so logs are equal to their exponent. 4x plus 2. So if we put this in exponential form, it's your base 5. Exponent is 4x plus 2, and it's going to be equal to 625. And we can actually go ahead and solve this. And we snuck in an exponential. Okay, so 5 to the first is 5. 5 squared is 25. 5 cubed is 125. And 5 to the fourth is 625. So we practice solving exponential equations. So 5 to the 4x plus 2 is equal to 5 to the fourth. Because exponential functions are 1 to 1, we can go ahead and equate the exponents. 4 to the x plus 2 equals 4. Subtract 2 from both sides and then divide by 4. So your exponent there is going to be, well, not your exponent, but your x is going to be 1/2. Okay. Some things that are going to be helpful when you're dealing with logs, and it's going to make it go quickly if you can recognize these three things, is what's log base b of 1, log base b of b, and log base b of b to the r. And what you can always do is, when in doubt, always set it equal to y. If it just says evaluate or what is this, and they're not going to say what is this. I might say what is this in class, but they'll probably say evaluate or simplify or something like that, and they just say log of blah. And they don't say equal to anything, so you can always set it equal to y. So if I don't know what the first one is, log base b of 1, I'm going to set it equal to y. B to the y is equal to 1. So your exponent's going to have to be 0. B to the 0 is going to give me 1. Okay, so log base b of 1 is equal to 0. So this is going to be kind of nice when we're graphing too, because that gives me a point pretty easily. At 1, when we plug 1 in, we're going to get an output of 0, so you'll have an x-intercept a lot of times of 1, 0. Okay. And, you know, there might be a test problem. What is log base 5 of 1? Well, if you remember this, it's 0. If you don't, then you can use your definition of log and set the thing equal to y, and kind of follow the procedure we did right here. Alright, let's find what log base b of b is. I don't know what it is, so I'm going to set it equal to y. So, writing it in exponential form, b to the y power is equal to b, which is the same thing as b to the first. Exponentials are 1 to 1, so the exponents must be equal. Okay. So y was 1, so log base b of b is 1. So that's another helpful thing. especially when you're simplifying down logs. If you have the base and the argument the same, then your answer is going to be 1. And finally, if I have log base b of b to the r, so it's b to the y equals the argument inside, b to the r. Exponentials are 1 to 1, so the exponents are equal. Y equals r. So log base b of b to the r is equal to r. So you can kind of see that the base here and the base here kind of cancel each other out, because exponential base b and logarithmic base b are going to be inverses of each other. So you're just going to be left with the x or the r, and that's a property of inverse functions. You also had that over here. You have the exponent of 1. That's what your answer is. The exponential and the logarithmic are going to undo each other. Alright, so here's what I was talking about before. Evaluate. When in doubt, set equal to y. So if you'd like to pause the video and try to do this on your own, you can. This says 2 to some power is 16. So you might be able to figure out, okay, well, 2 to the 4th is 16. But maybe that didn't occur to you, so you can set it equal to y. 2 to the y equals 16. And 16 is 2 to the 4th. Exponentials are 1 to 1. So log base 2 of 16 is equal to 4. Okay. If you want to try another one, you can go ahead and pause for log base 3 of 1 over 27. When in doubt, set equal to y. So 3 to the y equals 1 over 27. I know 27 is 3 cubed, but it's in the denominator. So if it's in the denominator, it's going to have a negative exponent. So 3 to the y is equal to 3 to the negative 3. Exponentials are 1 to 1. Okay, so log base 3 of 1 over 27 is negative 3. 3 to the negative 3 is 1 over 27. Alright, if you want to try this one, you can go ahead. Ignore the yellow ink for a moment. Log of 0.01. Remember I said that log is common log if you just see just log, so that'd be log base 10. So 10 to the y is equal to 0.01, and that is a penny. And a penny is 1/100th of a dollar. So 10 to the y is equal to 1/100th. Okay. 100 is 10 squared. Because it's in the denominator, it's going to be 10 to the minus 2. So 10 to the y equals 10 to the minus 2. Exponentials are 1 to 1, so you can equate the exponents. So log of 1/100th is negative 2. Alright, one more. ln of, sorry, I can't read it, e to the 5th. Okay, and I mentioned before that ln of x means log base e of x. Okay, so if you see ln, the base is e, and ln is just special notation for log base e. Okay. So ln of e to the 5th is equal to y. The base here is e, but we don't write it in. So e to the y is equal to e to the 5th. Exponentials are 1 to 1, and we can equate the exponents. So ln and e are inverses of each other. So whatever I plug in as input, input is going to be, let's not use it. Input is going to be whatever you put in here. So when you compose a function with its inverse, you get the original input. The original input was 5.